So here on our Delta Math assignment, we have solve linear systems graphically, level 1. So I'll click that. Okay. It should load actual equations. Let me refresh it. Please tell me Delta Math's working right now. There we go. Okay. So solve the following system of equations graphically on the set of axes below. So we have two equations, and I want to remind you that this is in slope-intercept form. So y is equal to mx plus b. This number over here that's added on the outside, this is 7. This is your y-intercept. That means on this axis, I want to click 7 because that's where my graph will touch the y-axis. And then you can see that I can make my line go anywhere. But over here, this number, it's a 1. I know you don't see a 1, but that's an invisible 1 in front of the x, which means your slope is 1. So then a slope of 1 means you're going to go rise up 1, go right 1. So this could be your next point. So I'm going to click over here, and as you can see, Delta Math has drawn our line for me. Okay, next. This is our second equation. It says y is equal to negative 1/2 x plus 4. So the plus 4 is your y-intercept. So that means I must go to positive 4 because it was plus 4 and click a dot here. So that's what this plus 4 is right here on our y-intercept. Now we have a negative 1/2 as our slope. Remember, your slope is a rise over run. So negative 1 over 2, that means you're going to rise negative 1 and you're going to run positive 2. So when you rise a negative 1, that means go down 1. When you run a positive 2, that means go right 2. So I click right here. And as you can see, Delta Math has drawn my 2 lines for me. And then with those 2 lines, they intersect at this one point. What is this one point that my giant red blocking thingy is covering? That is at the point negative 2 and positive 5. So negative 2 is your x value because you read it off the x-axis first. This is your x-axis. So it's a negative 2, and then you read your y value, 5. So negative 2 comma 5. Parentheses, negative 2 comma 5. Oops, comma 5. Make sure you type it like this with the parentheses, because when you type a point, you gotta type your parentheses and you gotta type your comma in between. And then you submit. Okay, let's do another problem. I'm gonna go as fast as I can. Why did it reload into this page? Okay, so we just did solve linear system graphically. Let's do substitution level 1. And I'm going to just show you the example and kind of read through it with you. So when you're solving the system by substitution, remember that's when you have one of the variables by itself. For example, here you have y by itself. That means where you see y in the other equation on this one, you're going to replace this y with what y is equal to. So in this case, we're replacing it with 4x because y is equal to 4x. So if I see a y over here, that means I can put a 4x there because y is the same as 4x. So instead of this y, it is now 4x. So that got substituted. So 4x is equal to 7x minus 30, and then you solve for x by, you see over here, they subtracted the 7x, so you got negative 3x is equal to negative 30 divided by negative 3, because this is x is multiplied by negative 3, so you do the opposite, you divide, and then that gives you x is 10. And then now that you know x is 10, we still need to know y. So you plug it into your equation. What is y equal to? Y is equal to 4x. Oh, I can't highlight it. But y is equal to 4x. So you plug it in over here. Y is equal to 4x. But what was x? 10. We know x is 10 because we just said that. So y is equal to 4 times 10. So y is equal to 40. Finally, you put it in x, y format. 10, comma, 40. Your x goes first. Your y goes next. Okay, I'm gonna pause my recording and see if you guys have any questions yet. All right, let's do another example. I'm gonna skip level 2, just go straight to level 3, just because of time. So for this one, it's the same thing. Solve the system by substitution. Let me show you an example so I can go through it here. So you have to look for substitution, you have to look for which variable is all by itself. In this case, x is all by itself. You see, sorry, not x. I can't read. This is a y. The y is all by itself. You see how there's like nothing next to it? It's just y, so this one's by itself. And so then you go look at the other equation. Okay, here's y, but I'm not going to write y anymore. I'm going to write what is y equal to? Y is equal to negative 3x plus 3. So you can see the 6x plus 9y equals 48 equation. 6x plus 9y is 48. Except instead of the y, they wrote negative 3x plus 3. So they substituted it because you don't want to write your y anymore. Right here, you don't want to write this one. You want to write what is y actually equal to. So we put it in there, and then they solve. So they rewrote the equation. You're going to distribute that 9. Distribute that 9. So 6x, 6x. 9 times negative 3x is negative 27x. 9 times 3 is plus 27 equals 48. Then they combined the x value terms, so they combined the like terms, and then it became negative 21x plus 27 equals 48. Subtract 27 on both sides, you get negative 21x is equal to 21. Divide by the negative 21, and then you get negative 1. So now that we know what our x value is, we are not done yet. Remember, you need to know what y is also. So take a look at your original equations. One of them tells you what y is equal to, because it literally says y is equal to negative 3x plus 3. This is what y is equal to. So you're going to plug your x value into this equation. So they rewrote the equation, and instead of negative 3x plus 3 is negative 3, negative 1 plus 3. Why? Because x is negative 1. We just said that right over here. And then you simplify and solve, you get y is equal to 6. Then you just put it into xy format. Remember, x is negative 1, so you put that first. Y is 6, so you put that next. It's pretty much just like the problem we did earlier, except now just a slightly more complicated equation. Okay, so that's substitution level 3. Then there's also determine number of solutions in a system. So let's show an example here. So you can solve this in any way you like. In this case, they took the top equation and they multiplied it by negative 2. And then you got negative 2x, and then negative 2y, and then equals negative 2 times 1, which is also negative 2. So they just distribute. And then they got these two equations. And then in this case, they chose to use the elimination method. So they added the two equations together. So when you add them, you see how it says add equations? Negative 2x plus 2x is nothing because they're opposites. Negative 2y plus 2y, that's also nothing. So on the left side of the equation, they got 0 because it was nothing and nothing. Okay, equal sign, they brought it down. Negative 2 plus 2, that's also nothing. So they got 0 equals 0. 0 equals 0 is like one of the most obvious true statements ever. It's like 0 is 0. Okay, I am me. A cat is a cat. 2 is 2. So like if they have the same number on both sides, this is always true, then that means you have infinitely many solutions, okay? And so we went over this in one of our notes before, but I just wanted to go over it again because we're reviewing. Now, if you solve for it and then you got like a number, kind of like in our previous examples before this category, if you get like y is equal to a number, or if you get x is equal to a number, that means there will be one solution. You don't even have to solve for the x. You know how we just know our y right now? If you know that y is one number, that means x is also just going to be one number. So there's going to be one solution total. You don't need to solve for the x value because our question isn't what is the solution? Our question is how many solutions. So if you get a number, you will say there's one solution. Let's see. Let me see if there's a no solution example. Okay, so if you solve it through and then you get a lie, like 0 is equal to negative 6, or 2 is equal to 10, or computer is equal to pencil, these things are not true. So if you get a statement that's just not true like this, like these are not equal, this is a lie. If your thing is lying to you, there's no solution. Okay, and once again, we did go over this before, but I just wanted to remind you right now because it's been a weekend. So that's this category. Okay, and then elimination strategy. So for this one, it's multiple choice. Elimination, remember, is like you want the same number but opposite. So like for example, here we have a negative 2y and another negative 2y. So essentially, if we want to combine these equations, you want to make this one a positive 2y so that they're the same number but opposite. So negative 2y and positive 2y. And I know it doesn't say that here, but the way you would get this to cancel out and eliminate is if you subtract the second equation. Because if you're subtracting the second equation, this is essentially a minus 2x, and this is essentially a plus 2y, and this would be a plus 12. That's what happens when you subtract it, right? Because it would flip the sign of everything when you're subtracting it. So if you were to subtract this equation, you would eliminate the y pieces. So you would click subtract to eliminate y. Okay, so that's this category. I guess I could submit this one. Why not? Okay, and then how much more time do I have? 5 minutes. Okay, cool. Let me show you elimination level 2. Find the solution of the system of equations. Let's look at an example. So for this one, remember, when you eliminate, you could multiply one of the equations by a number. So if you have 8x here and you have a 4x here, you're like, oh yeah, 8 is double of 4. So I can make the 4x into a negative 8x by multiplying the entire equation by negative 2. So that's what they did here. They took this equation, they multiply it by negative 2, so that once you distribute, you would get negative 8x plus 12y is equal to negative 20 once you distribute that negative 2. Then you have your opposites. They will eliminate each other. They will cancel out. You add it straight down, and then you can solve for y. Once you get one of the letters, one of the variables, you plug it into the equation, you get your x. Then put it in x, y format. Your x first and your y second. Okay? So after you get one of the letters, it's pretty much the same steps, whether you're using elimination or substitution. Once you get one of your variables, one of your letters, you just plug it into the equation and solve for the other and put it into XY format. Okay, last category, write system of equations from context. Show example. Okay, so here you would just have to read the situation. So Emma runs a farm stand that sells apples and blueberries. Each pound of apples sells for $3 and each pound of blueberries sells for $1.25. Emma made $58.50 from selling a total of 30 pounds of apples and blueberries. Write a system of equations that could be used to determine the number of pounds of apples sold and the number of pounds of blueberries sold. Define the variables that you use to write the system. So you can choose any letters, but here it says let A be the number of pounds of apples sold, and B is the number of pounds of blueberries sold. So A for apples, B for blueberries. And so they kind of take some sentences here. So like the sentence kind of appears here. So each pound of apple sells for $3. So A is pounds of apples. So A pounds of apples will bring in $3 A. Each pound of blueberries sells for $1.25. So B pounds of blueberries will bring in 1.25 times B dollars. So they have the blueberries dollars and the apples dollars. When you add it together, you should get $58.50. So you add it together and you get $58.50. And then since there's a total of 30 pounds of apples and blueberries, then if you add up the apple pounds and you add up the blueberry pounds, they should be 30. And so you just write the two equations. You don't need to solve them, you just need to write them. Okay? Okay, I'm going to end the recording here. I hope going over some examples was maybe helpful to some of you. And just don't forget that if that example wasn't enough, you can always click more examples. Okay? Stop.